Good morning. I hope everyone had a great week and weekend. But now it's time for us to get back to work and move on to a new math lesson and continue on with functions. Okay, so we're going to continue with the EQ. How can we define a function and apply it to a real life situation? Today's learning target is I can define and identify a function's domain represented in different ways. Okay, and we're going to talk specifically about a function's domain. So that's going to be the key word for us today. And let's start with the brain starter. Okay, the question is the graph a function? Why or why not? Okay, so the first thing that we should be asking ourselves is how can we determine if a graph is a function or not? The answer to that is we're going to be using what's called the vertical line test. Okay, so let's grab your pencil, or let's make a straight line like I have here. And we're going to be going from left to right on the entire graph. If you notice, this graph only touches our vertical line one time throughout the entire way from left to right. One time the entire way from left to right. So if it only touches the vertical line one time from left to right, you guessed it, the graph is a function, because if you use the vertical line test, the line only touches the graph once at all times. So let's make sure that we copy that down in our brain starter section, and we're going to move on to the mini lesson in just a second. Okay, the questions for mini lesson today. It's a little bit longer of a mini lesson today, but it's going to be very broken down as best as we possibly can break it down. The first question is, what is the domain of a function? Okay, so the first part to this question is the exact definition, which is the domain is the set of input values for which a function is defined. In other words, they're just asking, what are the x values? Okay, and there's many different ways that we can see a function, right? So the next question is, how can we be asked to determine the domain of a function? All right, so the first way is dots on a graph. The second way is ordered pairs. And the third way is a function on a graph. Okay, and the reason why I put these three in this specific order is because these two are pretty simple, the first ones. Dots on a graph and ordered pairs, they're pretty simple to identify. But a function on a graph, this is going to be a little bit of an extension, and let's see if we can do well with this. Okay, so let's make sure we're copying this down in our mini lesson section. Moving along to the last part of our mini lesson, questions part. How can we represent the domain of the function? Okay, we're going to be using what's called interval notation. Sorry about that. We're going to be using interval notation, which means we must be using these brackets. And we're going to be identifying the domain or the x values in those brackets. So where it says, for example, let's say we have an x value of 1, we have an x value of 2, we have an x value of 3, and we also have an x value of 4. We're going to be placing them in the brackets just like where it says, for example. That's how you would represent the domain of that function. Let's skip it. All right, moving along to the mini lesson. Well, the model problems, these are going to be the example problems that we go over together. We're going to go over each type of question that they would be asking you to identify a domain. Okay, so again, a domain is the x value. Okay, so when they give you dots on a plot, they're specifically asking you what is the x value for this dot, what is the x value for this dot, what is the x value for this dot, and what is the x value for this dot. Okay, remember we have to make our brackets. What is the x value for the first one? This one is -5. Whoops, that is not what was supposed to happen there. How do we get rid of this? We're gonna undo that. Undo, there we go. Okay, with -5, comma. This one is -3. Enough with this. This one is -2. And the last one is +3. +3, comma. And that's how we would represent the domain of those 4 dots in that graph right there. Okay, moving on to sets of ordered pairs. Again, all we care about is the x values, and we know in ordered pairs the x values are the first number in the ordered pair. Now again, number order does not matter, but if you want to put them in ordered in from least to the greatest, that's fine. So there's many different ways that we can organize the numbers. But if you just want to organize them from left to right, that's okay also. Okay, you don't have to put them from least to greatest. You can organize them how you see them. So we have 0, we have 3, we have -3, and we have 2. Now again, you can organize them from least to greatest again. So if you were to put -3, 0, 2, 3, that would be okay as well. Okay, as long as you just identify the x values. We do not care about the y values. We'll get to that another time. But the domain is specifically what are the x values of what is given. So far we've done dots, and so far we've also done ordered pairs. Okay, so if we were to scroll down to a function that is graphed, okay, right here we see a graph that is exactly what the brain starter was. Okay, so we care about the x values of this entire graph. So this entire graph starts at this x value specifically and goes all the way from left to right, so it includes all these x values until it reaches this x value. Okay, so we have to try and indicate that the domain, which is x, is from -1, 2, 3, 4. So x is from -4, and it includes -4 because the graph is closed. So that means x is greater than or equal to -4. And x is also less than or equal to +1, 2, 3, 4, 5, 6, 7, 8. So this right here is telling us that x ranges from -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So instead of writing all of those numbers out, you can say that x is greater than or equal to -4, because that's where it starts, right here. And x is also less than or equal to +8, because that's where it ends, right here. Okay? You want to try and identify a function that's graphed this way, so you don't have to list out all the numbers that's included on a graph. Okay, and this is going to be extra credit when you move on to the Google Forms, because most of the questions that you're going to see on IXL are going to be the questions that are asked above, which are the dots on a graph and the sets of ordered pairs, where you just have to identify the x values. Okay, so let's make sure we copy all of this down in our mini lesson section. If you have to go back and copy the rest of the mini lesson section, then please go ahead and do that. But for work time, there is a Google Forms that is attached. It should be, I'm not sure why it's not coming up here, but it should be on your screen. So the work time is going to be Google Forms. Let's make sure that we answer those efficiently, because these count towards your grade. And let's also make sure that we provide the Cornell note with a closing/summary. Now, the closing/summary has been very inconsistent for students. Okay? We want at least 1 to 2 sentences. 1 to 2 sentences. But the sentences can't be, "I did great on today's lesson." They must be talking about what you learned. And if you have any questions, the second sentence would be, or the third sentence would be, what questions you might still have. And I do answer some questions individually when I give feedback on how the Cornell note is handed in. Okay, so good luck on this lesson. If you need any questions, please feel free to reach out. I will also be live Wednesday at 12 p.m. And I will also be talking about this lesson as well as Wednesday's lesson. So if you have any questions, feel free to reach out to Ms. Grubb or myself. Thank you and have a great day.